In this problem, we are given the rate at which number of people are entering into a park on some certain interval of time, and we need to approximate the value of this integral using the right Riemann sum. So let us draw this curve using the given information. Time is taken along the x-axis and the number of people are given along the y-axis. So let us draw the points. Now this whole area is divided into 4 sub-intervals, and we need to use the right Riemann sum to find area of each rectangle on these 4 sub-intervals. When we are using the right Riemann sum, then height of each rectangle is decided by the y value on the right end points. The first rectangle is this. At 1 the y value is 4000, so height of this first rectangle would be 4000, and for the second rectangle height is 3125 because the right end point is at 3. At 3 the y value is 3125. Height of each rectangle is just the y value at the right end point. Draw the height from the right end point for each rectangle. Then we are going to find the area of each rectangle and then sum up all of them to find the area under the curve from 0 to 7. Area of first rectangle is width times height. Width is 1, height is 4000. So it's 1 times 4000 plus area of second rectangle is 2 times 3125. Area of third rectangle is 2 times 2000, and area of fourth rectangle is 2 times 750. So we get the approximate value of integral from 0 to 7 as 15,750. The total number of people entered into the park during first 7 hours is 15,750. Now let us see whether this is an underestimation or overestimation. We can see that this value doesn't give the all area under this curve. These small areas are still left behind. These small triangles, this area is still left behind, which is not included in this area. So this is definitely the underestimate. This value 15,750 is less than the actual area under the curve. So whenever we use the right end points for a decreasing curve, it always gives you an underestimate. Now let us see what happens when we use left Riemann sum instead of right for the same information. Now this area is divided into 4 sub-intervals. So we are going to draw the 4 rectangles over these 4 sub-intervals using the left end points. That means this time height of each rectangle is decided by the y value on the left end point. So for the first rectangle, left end point is 0. At 0 the y value is 4250, so the height would be 4250 and rectangle would be this one. For the second rectangle, we just draw the heights from the left end points for each interval. Then as we did earlier, we find the area of each rectangle using the same width times height formula. Width of the first rectangle is 1, height is 4250. Width of second rectangle is 2 times height is 4000 plus width of third rectangle is 2, and we get the answer as 22,500. That means the value of integral on the interval 0 to 7 using the left end point is 22,500, which is greater than the value we got using the right end points. This means for a decreasing curve, when we are using the left end point, this always gives us the overestimate. And why it is so? Because we have calculated the areas of these extra parts which is included into this area. So the left Riemann sum for a decreasing curve always gives you the value which is greater than the actual value. For a decreasing curve, using the left Riemann sum, it always gives you an overestimation. So we see that when we use the right end points for a decreasing curve, it gives us the underestimation. Whereas when we use left hand point for a decreasing curve, it gives us the overestimation.